Oh my goodness. Sometimes you just cannot make this stuff up, can you? I am, man, I'm having a great day. I hope you are too. Podcast chapter 8. And we are ready to begin. We're going to get straight into the stuff today, mainly because I know that there's a lot of questions and I know there's a lot of stuff that we want to go through. So get your pens, get your pencils out, get your reviews, come with questions. Let's get this party started. Here we go. Get the trumpet out, and we are about ready to begin. Again, if you've got questions, throw them on the top right over there on this side. I wanted to start off. Many of you asked me, you said, hey, Coach, what, as far as like this, the formula study sheet, do you have any advice on, how to remember everything? And so this right here, I pulled this offline. I wish I could have said I made it. I actually did not. Just pulled this offline. And what I'm going to do is just going to write in some specifics here and make sure that if you do have any questions, we can go through it and we'll go over those together. So as we go, again, we have two types of worlds. We have this p-hat world, and then we have our mean world. A lot of them have this, they have the same interpretation. The only difference is one, we're looking for the true mean, and the other one, we're looking for the true proportion. So I'm going to get my answer sheet up, and that way I've got it, and that way I don't mess up as I go through this with you. Alrighty, so delay. Come on. There we are. Okay. Starting us off here, we've got the left side of two types of worlds. All right, so let's talk about this. 8.2 focused on the proportion world, whereas the 8.3 focused on the mean world. So what we're going to do here is we're going to kind of write this in. So if you've got it, go ahead, write this in, and then we'll actually do FRQs related to these as well. So let's go through. So right up top, let's go. First thing is we know that this is proportion. We're trying to estimate a proportion. We know that one of the FRQs will be in the proportion world, whereas the other one will be more towards the mean world. Okay, so we'll write that in. The symbol for the statistic, it's a key statistic, is p-hat, whereas the mean would be x bar. Okay, remember we're using the p-hat and the x bar, the statistic, to estimate my parameter, right? So, which brings me to the next point. The symbol for the parameter is p, whereas x bar will be mu. Remember, in the p and mu, we actually have to put this in the state phase, right? Like we actually have to put it in terms of what is the true p, what is the true mu. You don't know it, but you're trying to figure out, or you're trying to find that there. The name of the procedure, this will go in the plan phase here, okay? So this would be more the state with the confidence percentage. The plan phase goes downward here, okay? So to the normal condition. The name of the procedure will be a 1 proportion Z interval. If you want to put 1 sample Z interval, you could, okay? And this really should be 4P, which is kind of redundant, but you just need the top part. And then a 1 sample T interval. Sorry, put this over here. 1 sample T interval for mu, okay? The random condition, is it SRS we're looking for? We're also looking for random as well. Over here, we're looking for the same thing. So these two would be the same, okay? Therefore, the quotations. All right, the next one, 10% condition. This is the second condition. So this is the first, the second. N is less than or equal to 1/10 of big N. That needs to be true in order to use the standard deviation formula. It relates to independence. So if something's not independent, then we have to use it to be able to say that it's so large that it doesn't matter. And again, as we've said it in the mean world, it would be the same over here as well. As far as the normal condition goes, the proportion world uses the law of large numbers. Very good. Which states that n times p is greater than or equal to 10, and n times 1 minus p is greater than or equal to 10. Okay? Now, over on this side, this is more of the complicated thing, so I'm going to write this in red, kind of a little bold over here. Statement 1, is the population, so remember the mean's a little bit more complicated, is the population distribution normal? That's condition 1. Condition 2 is CLT, which states is n greater than or equal to 30, my sample size. And if not, we then go to 3, where we're going to plot something, okay? Use a little histogram. Maybe we just kind of throw out an estimation of this, but we want it to be somewhat accurate, but it doesn't have to be perfect. We're looking for no skewness and no outliers. Now, if it's a little skewed, go ahead. Okay, if it's a little skewed, go ahead. But if it has major skewness or major outliers, then we'll move from that. Okay. All right, let's go to the next thing. We'll go in purple here. The next part of this, the formula for standard deviation. Okay, here's the key. Standard deviation is called standard error. Okay, so when we actually go to this, it's important that you know that when we talk about the standard error, each of these would be like the standard error of p hat. This would be the standard error of x bar. And we remember that for the mean world, it's the sample standard deviation over the square root of n. For the proportion world, it's the square root of p hat times 1 minus p hat all over n. Okay. The z star, t star, okay, we use z star for over here. We use t star over here on this side. The formula for margin of error is z star times the square root of p hat times 1 minus p hat all over n, right? So basically, it's these two multiplied together that gives me my margin of error. So margin of error could be my critical value times my standard error, if you wanted to be technical with it there, okay? And then over here, it's t star times s of x over the square root of n, okay? The general formula is for both is the point estimate plus or minus my margin of error. Just write it out. I know it's kind of redundant, but just write it out. And then the specific formula relates to p hat plus or minus z star multiplied by the square root of p hat times 1 minus p hat all over n. Make sure you write that down. And then over here is x bar plus or minus t star, s of x all over the square root of n, okay? All right, so this right here is a good sheet just to refer back to in terms of what's going down. I did not actually put down here, but anywhere from here down, this would be like the do phase. And then the conclude phase is pretty simple. Conclude phase is everything we've talked about. And we're actually going to go straight into that. So let's do this. That's actually a good place to start with this. And I know I'm hitting a lot of different things, but let's talk about this. A confidence level refers to 95%, 90%, whatever the percentage is. Okay, that's the level. The interval refers to the actual interval you find. You will interpret more intervals. I'm just making this up, by the way. I have no idea what context. I just made this up. But we will interpret more intervals when we go to the state, play, and do conclude. But don't slack on this, okay? So confidence intervals, what we've done, we are 95% confident that the true, and this looks like a mean, obviously, because it's not a proportion, that the true proportion or true mean, there I go again, is between 38.6 to 40.8, okay? And that would be what we put, okay? Confidence level is if, and by the way, put context in here. I don't have context, so, but put it in there. If we sample this, if we take many, how about if we take many samples, we would expect, let's talk about 95%, we'll just say, we would expect 95% of our intervals to capture the true mean. True mean or proportion, whatever we're talking about. Confidence level, confidence interval. Make sure you know the difference between the two, okay? Big deal on that one there, okay? There's also another question I wanted to go over, mainly because I think I messed up in the first class I taught it in, and it was this number 1 on check your understanding. I wanted to do this one, and then I'll get to questions. I apologize. I wanted to make sure I did go over this. Okay, so it says this. We want to estimate mu at 90% with a margin of error at most 30 minutes. Okay, so we want it at 30 minutes or more. A pilot study indicates that the standard deviation of time spent is about 154. How many students need to be surveyed to meet the administrator's goal? Well, the key is the margin of error was given. So we're going to take our mo and we're going to set it equal to t star times s of x over the square root of n. But the key is right now the margin of error would be 30, and t star would be something we just wouldn't know, right? We're looking for that. We're looking for t star. S of x is 154, and we're looking for what the square root of n is. But here's the kicker, okay? When we look at this specific problem, we understand that we do not have what little n is. We don't know it, which means that in order to find t star, we need degrees of freedom, and we also need the area of my tail. The tail's easy because in a 90%, we have 5% either side. So we would just say 5% would be my tail, right? But we can't find degrees of freedom because we don't have the actual sample size. I was saying that, I don't know what I was thinking when I was saying it in the first class, but basically because of that, we have to take t star and plug it in with not t star anymore, but z star, just in this context, because there's no way we could actually find it. So in z star, we go to our formula or we go to inverse norm. Okay, we can get rid of that. Inverse norm of 0.025, comma 0, comma 1. And we get 1.96. So 1.96 is z star, okay? And so what we get here is 30 equals 1.96 multiplied by 154 over the square root of n. And so what we could do here is just multiply across. So we're going to multiply 1.96 times 154. And what we end up getting is, it would take 30 is equal to 301.834 equals the square root of, over the square root of n. My fault. I don't know what I did there. So we're going to multiply by square root of n on both sides to get 30 square root of n equals 301.834. And so then I'm going to divide by 30, and then square it. So I'm going to divide by 30, square it to get in by itself. Sorry, let me do this one more time. 301.83 divided by 30, and then square it. My fault. So I get 101.22. So I would say approximately 102. Okay. All right, I hope that was right there. I hope I attacked that right. Let's see. Did I not? That was a bummer. I must have. Did I put, I think I might have messed up. Let me say it again. I think I did the inverse norm wrong. My fault, y'all. I was doing it on my calculator. Inverse norm of 0.05. Yeah, I did 0.025. My fault. 0, comma 1. Yeah, it should be 1.645. So it should be here. Same process, multiply here, right? Divide by 3, get the end to the other side, square root of n, square it, and there we go, okay? So this was for 95% confidence. Just be sure that it was for 90%, and that's my fault. But just want to make sure we go over that process that's there. Michael had the first question related to the study guide. And again, you're probably thinking, Coach, come on, get to my question. And I will for sure, but right here, it's a good one. It says a company produces pens. How long will the ink run out? sample of 49 pens, so n equals 49. The mean is 188 for those pens, so we'll say x bar is 188. The standard deviation of the sample is 6 hours. And so create a confidence interval. So real quick, this is just a highlight here. If I need to go over it specifically, come back and let me know. But the true mu is the, as I look at it, how long pens will last for the company. So all pens, right? Like the average of all pens. The confidence percentage would be at 95%. The plane phase, a couple things. It is random sample right here. So we're good there. 10% condition, and I would actually state this. I'm doing shorthand, which is totally not good for the test, but I just want to make sure we can fly through. Michael had a question on the B and C, and so I'll get to that. 1/10 of all pens. So this would be, if I was writing this, all pens. Okay, cool. That's going to be true. So that's going to be true. The next part is make sure I'm good. Okay, good. The next part is the normality, so normal condition. And so the question is what does it say about the population? Doesn't say. So we go to the central limit theorem, which says is n greater than or equal to 30. And in fact, it does say, and I would actually write out central limit theorem because 49 is greater than or equal to 30. Sorry, I can't go any further. Let's see if we can push this over. Okay, so that's true. So then we go to the do phase. Make sure we do estimate plus or minus margin of error. Then we'll plug in x bar plus or minus t star over times s of x over square root of n, where I'll plug all the values in, and then I'll get out my confidence interval, and then I'll conclude it. Okay. All right, good stuff. We kind of did a Cliff Notes version, but that's good. B said the head manufacturer of the company claims that this mean will operate at a mean of 190 hours. Does the company's claim seem justified? Well, let's do this. Let me, what's up, y'all? Sorry. I don't know why I did that. Just felt it. You know what I mean? Like, just do it. Just do it. I hope the yeast is going well for you today. Hope the yeast is going well. All right, pulling it up. Go from there. All right, I popped it. I'm waiting for the calculator. So if you think like, Coach, come on. I know. I'm popping it right there. That's right. All 8 of you, you're impressed. Don't lie. You know. That's a bad hair day. Sorry about that. Sorry, that's really embarrassing. All right, come on, calculator. Y'all have a lot of questions because I haven't even looked at the YouTube thing yet. Let's see here. Come on. Pull up. If not, we might have to just talk it through. So we'll see. I thought I was all clear on TI calculator here, but we'll see again. While I'm waiting here, let me just kind of let me go over it with you, just the process of it on your calculator, and that way you know where to go. Okay. So if I was finding part A on my calculator, I did it with the first class. I don't know if I finished this with the second class. So my apology if I did not. But you can do this on the calculator by going to one sample T interval on your calculator. It also could just be T interval for yours. Okay. For the actual proportion, it's 1 prop Z int, I believe is something like that. Okay. Don't go to the test. If you go to test, I will haunt you in your sleep. Okay. Do not do that. Please do not do that. Okay. Cool. All right. Hold on just a second. I'm gonna see if this will work. This will be huge if we can get this calculator running. Bum, 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 bum. Okay, it's not working. Okay. Let's do this then. Let's pull this back up. Okay. All right. So this is what I was just talking about, and my apology. I could show it to you on the actual calculator tomorrow. I don't know why it's not working here. I might have to start my Mac over. But go to stat, test, and then T interval for means. Okay. The X bar is what was given. Obviously, that would be 49. The S of X would be 188. The size of N, I'm sorry, I think N would be 49. The mean is 188. My fault. 188. 188 is the mean. S of X is 6. That's right. And we want a 95% confidence interval. Again, you got to show this, so just as a heads up. But this right here would be 186. And this is really, to be honest, this is really important for tomorrow. I believe there is one like this on there, okay? So this right here up on top, once I did the actual do phase, I get 186.228, comma, 189.72. So when I do this, that would be the interval. The question is in part B, the head of the manufacturer of the company claims that this mean will operate at a mean of 190. Notice is the mean inside of the 95% confidence interval? No, it is not. So it's actually in the tail. It's like out here, out yonder, out here. Okay. So we would say the claim the mean will operate at a mean of 190. Because this is 95% of it and it's outside, we have convincing. This is how I would write this. We have convincing evidence to say that the mean will not operate at a mean of 190 hours. That's kind of wordy, but I'm just copying what they said, okay? Since 190 falls outside of my, and I would even say is greater, since 190 is greater than my interval between 186.28 to 189.72. And you could say something about this being statistically significant. It falls within my 5%. Okay. So it is less than 5%. So you could say something about being less than 5% here. Okay. But these two things are not needed, but are really good things that maybe you just hold on to later on. C says, what is the probability that another random sample will have an average of 190 hours more or more? What is the probability that another random sample will have an average of 190 hours or more? Okay, so first off, this N is 49, right? And what we're trying to do is we've already shown that we can use the normal condition up here, right? Because it's the central limit theorem. So there's no need to do that. But what we could do is then say, okay, let's not mess around. Let's try to see here. First of all, we know mu of X bar. This is, I think, using the sampling distribution. I'm going to actually look at this, Michael, because I had a question about this one as well. I just want to quickly. Hold on. Living on a prayer. Take my hand. Living, I swear. Oh, you didn't know you get some karaoke there, did you? Living on a prayer. What y'all gonna do when you get to college? You don't have teachers like this from GAC who sing, and I mean, what are you gonna do? No, I know what you're going to do. You're going to log into these help sessions just because you miss it. I know you. I know how it's good. I know how you do. I know how it goes. I'm pulling up something up real quick. Literally, I'm Googling it. So if you're thinking like, oh, coach, you solving it. No, not really. I'm literally pulling this up. So I know that that's probably bad. But looking at it real quick. The question that I had is, here, how about this? I'll start it, and maybe you can help me. So as we look at this, mu of x bar is equal to my mu, right? The reason why we're looking at this is we're looking at what is the probability that another random sample will have an average of 190 hours more. We're basically asking for where's x bar greater than or equal to 190 using a normal distribution, right? So it's basically 190 or greater than, right? The standard error would be like the sigma of x bar. It's not, yeah, I guess with the standard error would be s of x over the square root of n. So this would be 6 over the square root of 49, or 6/7, right? That would be the standard deviation. But because we don't have mu, I'm guessing this is a sample though. It's not actually the population. I would use 188 from up there. That doesn't make sense. But if I use 188 and then did normal CDF of 190 and anything greater than 190 with a mean of 180 and a standard deviation of 6/7, I think that dog will hunt. Let me see. Normal CDF, lower bound 190, upper bound 9999, comma 188, comma 6 divided by 7, or 6/7. I got 0.00982. You know what I mean? The problem is that I don't know what the actual true mean is, right? So we don't really know that. So that's extremely hard to find. If I'm wrong, please post that, because I know that my process is right, but my big thing is, where do I get this from? I don't see it. I used 188, which is a sample, but it could be referring to just the top part above it. But I don't know. I don't know. That dog will hunt, though. That dog will hunt. All right, Michael, and all the questions are answered that I knew of before today. So we're going to go ahead into our questions. Oh, man, there's a ton. Let's start with it. Can we go over the MC review? Yeah, we can do that. Remember that. And what words in an FRQ would tell us it is proportion world? Like, how can you tell? Kristen, that's a great question. What's up, Brianna? I'm literally at the top, so I apologize. Yes, we can go over the mean world FRQ. What? I think we just did that. Brianna, please touch base with me. I can do another one, like do the full gamut, okay? In fact, I probably will do that. I'll probably do one mean world fully. That's there. So do we need to show the 10% part of questions using the Mo equation, asking for like Mo or same? Yeah, Lindsay, you do not have to show 10% if I'm looking for sample size, or if that's all I'm looking for, okay? You do not have to show it. Great, great, great question. I love it. Emily, can we go over number 63 part B on? Yeah, we can do that. We're starting to get to, and Ryan, you checked me on it. Okay, so some of you have some questions that I'm going to get through. Multiple choice review, we are definitely going to do that. And then Kristen said, whoop, whoop, by saying, yeah, that's something we need too. So let's go through, yeah, let's do this thing. When do I use each? Okay, so I've got 3 FRQs. I want you real quick, if you think, man, I don't really know this, pause me right now, okay? And see what one would I use in each of these scenarios, okay? And what I'm going to do is I'm going to take a mean, and I'm going to actually do the full thing. I'm going to time myself, and in fact, I would do this too. I would time yourself as well. If you are looking for more multiple choice, feel free to go backwards here. Where are you? Oh, coach, mess, and you might have to ask some of your classmates for that code. I don't have that, I don't think. My apology. But right here, this would be the 3 FRQs that would be good just to kind of review over and go through. So as we went through number 1, or as we go through number 1, let's see. Suppose we're interested in finding out the proportion, that tells me we're proportion world of the population at GAC that has seen The Office. Okay, we contact an SRS of 100 students in the school. Of those 100 students, 63 report seeing The Office. So right there, we know that P hat, because of a proportion, is equal to 63 over 100. And then we go SPDC, state plan to conclude, right? Numero 2, Coach J has done over 50 tracks at Dixie Speedway in Woodstock, Georgia. He uses his Honda Civic, no laps, please, and has found that they follow an approximately normal distribution. That's pretty intriguing. A random sample of 9 laps show a mean lap time of X bar with a standard deviation of S of X equals 0.3.2. Create a 90% confidence interval for Coach J's career average lap time. Okay. This is a good one. It's a really good one. Can we just kind of stop here? First off, shows a mean. We're in mean world. Okay. So when we do SPDC, we know that we're going straight into mean world. Why, you may say? Everybody say it. Because it says mean. Got me? Now, sometimes it doesn't say that. Sometimes you have hints like X bar or something that says we contact an SRS of 100. Of those 100, 63 of the 100. That's a proportion, right? And so on and so forth. Let's go to the next one, and then I'll come back to 2. Coach J was an all-star basketball player in high school. To prove that he still has skills, he took 50 free throws and made 31 of them. 31 of them. That should be a hint. Think of these 50 shots as being a random sample of all free throws oh. It's a podcast. Yes. So for the true proportion world, right? So again, there's going to be major hints in telling you which is which. Let's go over number 2. Okay. I'm going to put a timer on. If you want to pause this video, it might be a good idea just to kind of run through this and time yourself and see, hey, how long did this actually take me? And then check it with me. Okay. And actually check me too, because sometimes I know it's easy to forget some things as well. Okay. Alrighty. You should be able to do this in 12 minutes. On your mark, get set, go. Coach J has done over 50 tracks at Dixie Speedway in Woodstock, Georgia. He keeps track of each of the laps and found that they follow an approximately normal distribution. That's a hint. A random sample of 9 laps shows mean lap times of X bar and S of X. So I know what we're talking about, right? We're talking about mean world. So we're going to go into the state. So my state says, what is mu? It is the true mean. Sorry, I'm going to push this way over here. True mean of the lap times for Coach J. And you could say all the lap times for Coach J. And this is at a 90% confidence interval. Okay? All right, good. Plan. Number 2. We need 3 things. We need the random condition. And it said that it was a random sample. So random sample of 9. Okay, we're good. And by the way, little n is not 9. Got me? Maybe just hold on to that. Okay. Condition 2, 10% condition. Okay, so we're going to run through the gamut here. Little n is less than or equal to 1/10 of big N. Little n was 9 is less than or equal to 1/10 of all laps. And that's appropriate. Just check that off because we know it's true. It's condition 2. Condition 3, normal condition. And we look first at the population distribution. So it says that the population found an approximately normal distribution. So we would just say that the population distribution is approximately normal. Okay? There's the plan phase. Let's go to the do phase, okay? So the do phase tells me that it is estimate. I forgot something, and I'm going to get there. Plus or minus margin of error, okay? By the way, what test am I using for the plan phase? One sample t interval, okay? That's the test. Estimate plus or minus margin of error. So this is x bar plus or minus t star times s of x over square root of n. Let's plug and chug. So 102.4 plus or minus the t star. By the way, t star, let's talk over that real quick. Remember that in a 95%, oh, I'm sorry, 90%, I think I put, yeah, no, we're good. 90% here and here. My tail would be 5%, right? So this tail would be 5%. And my degrees of freedom is n minus 1. So since I did 9, minus 1 would be 8. So in my degrees of freedom, you could either do two things. You could go to your table B, or you can go to inverse T. You could actually do that. Go to inverse T. Same thing. It's on your same parts. So go to your calculator function. Go to second vars, inverse T. Second vars, inverse T. Your probability, mine looks a little different. I don't know if yours does too. Inverse T, my probability was 0.02 or 0.05, comma. And I think I want to just double check because my calculator on my phone's a little different. But you could definitely do that part, especially if it pulls it up there. So I'm going to actually go to table B. My trumpet noise is on point, y'all. I should go into the I should be in the band just trumpeting my voice, you know what I mean? I could just do that. I see it. I think it's pretty good, pretty solid. If it's annoying, just put it in there. Just put it. I'm just curious. I want you to vote on the YouTube link while I'm finding this on table B. And in fact, I want you to just know that I'm just wasting time right now. But I know I'm on the clock. You know, I'm trying to get this done in 12 minutes. But I want you to know that we have time. We have time. We have the degrees of freedom of 8. This is table B. Because remember, we're talking mean world, right? If we were talking about the Z star, we would be talking about 0.025 or 0.05, my fault, 0.05, which would be about right in here. And so that would have a Z-score of negative 1.65. But we're not talking about that. We're talking about mean world here. So we're going to go to the degrees of freedom of 8 with a 0.05 here. And so we would have a T-star of 1.860. 1.860. We've got it. Okay, let's see here. 1.860. Okay, there we are. Okay, so we got 1.860 here. 60. S of x would be, I think was given, it's like 3.2, right? And if they gave me a list of numbers, like, you know, and they just gave me all these lists, 1 var stats to find the same information. Okay, 1 var stats and you're good. And this would be all over the square root of 9. So we're just going to plug and chug here. 1.860 times 3.2 divided by 3. I hope y'all are having a great day today. I hope you are. I'm just being honest. Okay, plus or minus plus 102.4. So this is 104.384, 104.7, thefishatlanta.com. Some of you watch The Fish, listen to Fish, I'm sorry. Maybe. Maybe you don't. Maybe you don't. And if you don't, that's okay. We won't judge you too much. All right, here we go. So this right here is the confidence interval. And so we've done the do. Let's go to the conclude phase. We'll put it over on this side. We are 90% confident that the true mean is between the interval of 100.46 to 104.384. And then over here, ... I would actually put the context as it relate. Actually, you could put it here probably that the true mean of all the lap times for Coach J is between the interval of 100.46 to 104.384 seconds. Cool? Cool. What was my time? Let's see what my time was. I did that right there was done in 7.5 minutes. Cool. 7.5. So I say all that to tell you, I'm telling you, if you know what you're doing, you can dominate those FRQs. I'm telling you, you can dominate the FRQs. But you've got to work. Got me? You've got to know the stuff. You can't be like, oh, I don't know. What was it, this or this? You got to go after that stuff. And if you do, I'm telling you, you're going to dominate tomorrow's test. Have complete confidence in that. Okay? Complete. I was going to look at, I'm actually looking at the test right now. Should I just show it? I can't show it. I can't show it. I can't. Oh, standard air. Okay. All right. I'm actually doing this. I can't believe I'm doing this right now. You're on the podcast, right? What, I mean, so what, right? So what? Okay, I'm going to do that. I'm literally taking screenshots of this. Okay. Alrighty. I'm fine with that. That's fine. It's good. Good. Yeah, right now I'm literally looking right now. Please make sure you know how to use a confidence interval. And then from that to see whether, see whether the claim is true or not and determine that based upon whether it falls in the confidence interval or not. I did it in the previous part of the podcast. So if you're watching right now, then you are fortunate. Go ahead and do that. By the way, this is not, I want to make sure I look at you at this. Okay. So this test is not cumulative. Okay. So it's only over this chapter. So know that. All the concept lists are there on chapter 8. Check that out. We can always come back to that if need be. Okay. So if you have any questions on that, we can go over that. Cool. Yeah, I'm going to do this. I can't believe I'm doing this. All right. So last year when we actually had this test, I'm going to put it right here. Okay. Y'all, this is part of the test. Okay. This is part of the test. All right. So if I were to first of all, this is standard air, right? Does everyone go with that? Like that is standard air. You need to know that. Standard air. Know the standard air of X bar as well. When I go to, and know like the definition of that, right? And know that margin of error equals Z star times my standard air. So technically the mo is the critical value times p hat times 1 minus p hat all over n, right? If I say, if I'm referring to proportion and I say, give me a 90% confidence interval for the proportion of level C, okay? Know that p hat is equal to 272 over the total. Add them all up. I don't even know what that would be, to be honest. Add them all up. Let's say it's 1,200. I don't care. 1,200 is your little n. Got me? That's the sample size. Whatever the total is. I don't know if that is or not. I'm lazy. But for right now, for this. I just want to make sure that you understand how to find that p-hat value. Okay? Cool. All right. I know that I've not interacted very much with y'all. I apologize. Chris and I hit on a lot of them. Ryan, I've not forgotten about you. Okay, I'm coming. Mean World FRQ, we did that. 10% condition, we hit that. 63 part B, HW 8.3. Okay. Some of these we might have hit, so if so, I apologize. I'm like really far behind today, y'all. Alrighty. Brianna, did you get the Z-Star? If you did not, I would say I would ask someone in class about that. I know that that's maybe cheap, but I think that might be better. I don't think there's one major one on there. The big thing is use T-Star unless I don't know the sample size. Then I have to estimate using Z-Star. But if it's the mean world we're talking about, right? We're talking about mean world. If it's that, we want to make sure we estimate using T-Star. Okay? And then go ahead and into Z-Star if we don't have it. All right, here we go. Number 63. Part B, a hasty reader believes that the interval given in the table is a 95% confidence interval for the mean height of willow plants in the region of the park. Find the actual confidence interval for the given interval. Okay, I don't like this question, but we'll roll with it. So 19.03 is the standard error. You say, Coach, I thought it was margin of error. It actually is supposed to be. It's supposed to be this, right? But they put S of E, and I think that confuses people. Well, let me just show you what this would end up being. So if this is true, this would mean that 23 plants, right? We have 23 plants. They're saying it's 95%. We're saying, nah, that's not true. 19.03 is what is over here. So this, we're going to set the Mo is 19.03, and we're going to set that equal to, it's X bar, so T star multiplied by the square root of, times S of X over square root of N. Square root of N is 23. S of X is, I think you actually had to sample standard deviation with these measurements. How did we get that? I did that earlier. Did they give us a table over here? Let's see. Oh, okay. Oh, I hate this question because it almost confuses us. I shouldn't have put this here, y'all. All right, let me just quickly go over this. So basically, they're saying, don't look at this. Don't look at this. Don't look at this. It's X bar plus or minus margin of error, and I'm trying to teach it so I don't confuse the heck out of you. Just say that they gave us that the standard error of X bar was 19.03. Okay, just go with that. And since that's the case, 19.03, we know that the standard error X bar is equal to S of X over square root of N, right? The question is what is the standard deviation of the sample? Well, we know this is 19.03 equals S of X over the square root of 23 because it was given. So when I multiply by square root of 23 on either side, I get S of X by itself, which allows me to do 19.03 times the square root of 23. So this would be 91.26, just like that. So that would be the actual S of X, and then go from there. Here's the thing. Part B, I do not want to go into that because it confuses you. I want you to cross that out. I did it with someone today in class, but it's confusing. If you know how to work backwards on Part A, Kristen, you're good. Okay? Cool. All right, hit that. Oh, man, I'm really behind. Charles, get out of here. Oh, man. Oh, wow. I can hit that. I'm just saying. Oh, okay. Haunt you in your sleep. Remember Coach J Fan Club. Oh, what's up, Mom? What's up, Lindsay's mom? Good to see you. My mom was like, he's so small when I showed her the video of him falling. Well, thank you, Ryan. Appreciate it. Hey, you know what? I've got moms in the fan club. Everyone can join. Enjoy it. Yeah, let's get you there. All right. Table B is so helpful because I don't like using table B. Oh, I'm sorry. I'm back a little bit. Charles, this might be the worst podcast ever. The do is uncalled for. Okay, Charles, no judgment. Really, seriously, stop. Y'all are hating on me. Well, my mom was like, "Oh man, Coach, watch Khan Academy." Charles, hey, you go watch Khan Academy. See how you do tomorrow, okay? I'm just messing. That's bad. Please don't. Please don't. Okay. All right. Very good. Will you be in your room tomorrow morning? Kristen, tomorrow morning, I actually will not be in there tomorrow morning. I'm sorry. Friday mornings, I've got Waffle House, and I apologize. I can do this though. I will try to leave my classroom open if you would like to go there. You absolutely could do that. Okay. Actual confidence level, I was lost. I think that was the one I just did. That one was weird. The QR code and multiple choice was hard. I could do that one maybe instead. Maybe that's one I do. 77 on 8.3. Okay. So worst podcast ever. Well, thank you, Charles. The review for the test is Charles, you are a hater. So you know what? It's all right. Just because I can pop. Shane, it's the extra multiple choice and FRQ. I hope you found that. I'm sorry. Fur. We are all fur. I'm just rolling down. I'm going to go the multiple choice, Ryan. That's what I'm going to finish off with. Inverse T, Brianna. Inverse T. INV, inverse T, which is right below inverse norm. Okay. Just make sure you use inverse T. You could do that. Okay. Perfect. Yeah, I might be able to do 63. We'll see that one. I'm going to get to Ryan's. Twinsies show the test. Oh man, what legend shows we are dedicated. Alrighty, very good. A Santa hat. Okay, wow. Offended. Oof, I definitely meant to say 65. Okay. Brianna, that's a little appropriate. Brianna. Scroll up. Lemaha. I don't know what that means. Proportion interval button on the calculator. Okay. The proportion interval is one prop z int. One proportion z interval. Okay. All right. Cool. And Charles, disrespectful. Thank you very much. I'm at the end of the comments, y'all. I am going to go back to the multiple choice. I may or may not have hit your question. I was looking and seeing on anyone specifically on the homework. 63 was the one that I think we already went through 63, didn't I? 63. I think we did 63, didn't we, Lindsay? I think we did that one. Kristen, I think you had another one, 70, or Emily, you did 77. Let me look at that one. I'm just kind of talking through. Why is it B instead of D? That one was a hard one. That one was tough. Okay. Actually, I do want to look at this one. Let's take a look here. All right, first off, let's talk about ones we can actually exclude. So first off, it says the smallest margin of error, right? The smallest. Well, let's talk about margin of error. What would produce the smallest margin of error? Well, as we have less confidence, so the less confidence is the smaller mo, right? Smaller mo. And higher sample size, that also decreases my mo. So I want something that has the least amount of confidence and the highest sample size. Well, at any confidence level, even though this is really large, they work hand in hand, and so that would not do the trick, okay? The next thing is what would have the least amount of confidence with the smallest mo? Well, the least amount of confidence and the highest sample size should be, Kristen, I was getting to your question. I'm sorry, Emily. It was Emily. Kristen had it first, and then I had Emily. Oh, yeah. So good question. The reason why it would be B instead of D is because if I have the choice between B and D, if I have a smaller confidence level, right? These are the same thing, right? Other than the confidence level. If I am less confident with everything being the same, okay? Hold up. No. Okay, so if I want to be if I am less confident, that would contain a smaller interval. But if I want to be more confident, right? Like if I want to make sure my interval is 95% sure, this thing is going to expand just a little bit. Does that make sense? So that's why this would produce the smallest margin of error. The higher confidence I have with everything being the same, the higher confidence I have, I need to have a larger interval in order to have a higher confidence that it captures the true mean or proportion. That's actually a great question, Emily. Good one. Good one. Okay. Y'all, I am running out of breath right now. I'm not going to have a voice tomorrow, but it's going to be okay. Okay. We're all going to, never mind. Forget it. Never mind. Almost said something. All right. Let's go to our Google Docs here. We're going to go to, I'm going to pull this up here. I'm going to go to my Google Forms. And I'm going to go over this. Chapter 8, test review. And I know that some of you maybe, from what I heard, the review questions were a little bit easier than this one. So I want to make sure I go through maybe some of the tougher ones. And if you do have any questions on them, like what one was the answer, use the YouTube stuff on the side just to say, hey, what was that question? And maybe some of your peers could kind of go over that as well. Okay. All right, let's go over a couple of these and then we'll be out of here. The Gallup poll interviews 1,600 people. Of these, 18% said they jog regularly. The news report adds the poll had a margin of error of plus or minus 3 percentage points at a 95% confidence level. You can safely conclude that what? Okay. 95% of all Gallup poll samples like this one give answers within plus or minus 3% of the true population value. That sounds pretty good. Let's go to the next one. The percent of the population who jog is certain to be, well, that's false. 95% of the population jog between, that's false. We can be 95% confident that the sample proportion is captured by the, this is key. Sample proportion. They're trying to trick you. Not sample, population proportion is captured. And then E, if Gallup took many samples, 95% of them would find that 18% of the people in the sample jog. Well, that's actually false because it would say if Gallup took many samples, 95% of them would capture the true proportion, right? The only one that would make sense is this, that 95% of all Gallup samples would give us an answer within plus or minus 3% of the true population value, okay? Cool. And it's just a fancy way of saying captures the true proportion. 8.2, the weights of 3 adults are this. The standard error of the mean of these 3 weights is, remember standard error is S of X over square root of N. So to find the standard error, I plug these in for L1. And then once I plug those in for L1, I get the standard, I did the 1 var stats, right? 1 var stats. And then once I do 1 var stats, I then divide that by the square root of 3. And then that's what would get me my standard deviation. Okay. Again, standard error. In preparing to construct, and again, remember talking about mean, and that's why we did S of X. Cool. In preparing to construct a 1 sample T interval for a population mean, suppose you are not sure if the population distribution is normal. In which of the following circumstances would it be not be safe constructing the interval based on an SRS of size 24 from the population? All right. So, this one says a stem plot of the data is roughly bell-shaped. Well, that kind of proves the point, right? Because this will fail the central limit theorem. So we're looking for what would then go to the third condition, which would have major skewness and an outlier, okay? B would be a histogram shows slight skewness. Well, I'm good with slight. I'm good with slight. We're talking about major, okay? C, a box plot of the data has a large outlier. Yeah, C would be the answer here. Because then it goes, the sample standard deviation is large. I don't care about that. A normal probability plot of the data is fairly linear. I don't necessarily care about that. All I care about whether there's large outliers and major skewness. Okay. Cool. 8.4. Is this helpful, by the way? I know I'm kind of talking. Oh, are you good? Okay, Ryan. Ryan, do this. As you look through those multiple choices on the other one, throw a little question or two, and I'll put those on there, okay? I'm going through this one because you said it was tougher, and I agree. This one actually is a little bit harder. So I think this one actually would prepare us better. Many television viewers express doubts of certain commercials and attempt to answer the critics, wish to estimate the proportion of consumers. That's key, proportion. Let P represent the true proportion of customers who believe what is shown. What is the smallest number of consumers that Timex can survey to guarantee a margin of error 0.05 or less at a 99% confidence level? Well, this would be where I would set 0.05 equal to Z star times its standard error, which is square root of P hat times 1 minus P hat all over N, right? So that's what I would use on that one. Cool. That's what I would use. Let's see if I can actually do this. I've never tried this before. Let's try that. Let's try this here. I don't know if that will let me do it. No, I don't think it will. Cool. It's all good. I was trying to write on there, but it's not letting me do it. My apology. But that's how I would attack it. And again, the big thing is and the reason why I would attack it that way is because it gave me the margin of error, and it says what is the sample size. So you would set that margin of error equal to the Z star times square root of 1 minus or square root of P hat times 1 minus P hat all over N. And so that's what I would do on this one. If you're questioned on this, go to your check your understanding. I also have it on the podcast as well. You want to compute a 90% confidence interval for the mean of a population with unknown population standard deviation. The sample size is 30 with, by the way, D of F or degrees of freedom is 29. The value of T star you would use would be what? Well, the till percentage would be 5% on either side with degrees of freedom of 29. And then that's how I would find my T star. Okay. And then it would go in the middle. Inverse T or table B. Okay. Either one of those. Oh, these are always fun. The 1, 2, or 3. A radio talk show host with a large audience is interested in the proportion of adults in his listening area who think the drinking age should be lowered to 18. To find this out, he poses the following question to his listeners. Do you think that the drinking age should be reduced to 18? Okay, so of the 100 people who phoned in, 70 answered yes. That's a key for proportion, right? Plus it says it. So which of the following conditions for inference about a population using confidence interval are violated? Okay. The data are a random sample from the population of interest. What is violated? Okay. Okay, he did it just to his listeners, right? So because he did it to just his listeners and they phoned in, that's not a random sample, so that would be violated. That would be number 1, which eliminates B and C. So that's good there. The second one is the population is at least 10 times as large as the sample. It's like the 10% rule, right? The sample size was 100. I would say there's more than 1,000 listeners. I would say that this would be okay. I would say this is okay. So I would say 1 is just the only one that I see so far. It's either A or E. Or I think the only one that would be is A. What's the large audience, right? So the only one that I see is 1 right now. And N is so large that both N times P and N times 1 minus P are at least 10. I think that's still good because that would be 0.7 times 100. Yeah, both of those would be okay. So only 1 would be A. Yeah, The answer would be A there. Okay, 90% confidence interval. We'll do the last one here. Mean of a population is computed from a random sample and is found to be 9 plus or minus 3. Which of the following could be the 95% confidence interval based on the same data? Okay, so 95%. Okay, 95% would have a larger margin of error, right? Ooh. Ooh, that is tough. I'm not looking at the answer on this one because this one's challenging. Huh. No idea what's going on up there. Sorry about that. I don't know. 90% to 95%. I would lean towards E, but I'm not sure. I know that 95% would have a larger margin of error. So I think that would eliminate these two here, and it would go to C and D. But because we don't know the sample size, I would say it's C, D, or E. I would lean towards C, but I'm not 100% sure. Is that right? Yeah, C, but because it's larger, but I don't think it would be that much larger from a 90 to 95%. Because again, a larger percentage confidence interval would have a larger margin of error. I wonder why it couldn't. I'm guessing because it's just not that much larger. So I would say that would be the only feasible one. That's funky. That's funky. 8, if you want to pause it here, you can. Here's the answer. You can go back at it. So D of this one. Cool. Over here, this one, question 9. The answer is E, if you want to go back to that one. Cool. And number 10, this answer is D. So if you want to try to pause that, go back through. And that is it, ladies and gentlemen. Woo woo! I popped it. I popped it again. Dab, 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 dab. Right, Charles? That's right. That's for you. That's for Charles. Charles, you know what? You complain about these podcasts, but you keep showing up. You do. You keep showing up. I know there's a little piece of you that you're just going to miss it. When you go to college, you're going to be like, Coach, where were you in college? I miss you. I miss you so much. Yeah, that's right. I'm on this because I'm not pressing. Lindsay, what's going on? What are you not? Are you struggling? Here's the deal. If you have major questions, I would just spend some time tonight going over the podcast and practice. Okay. As you go through, and wherever you're at, you know that there's going to be one FRQ that's proportion, one FRQ that is related to the mean. And what I would do is just attack it. State, plan, do, conclude. Got me? I'm telling you right now, if you do not, if you don't do well on the state, plan, do, conclude, on the mean and on the proportion, man, it really is on you, because you know exactly what to do. You've got the things set up. Go ahead and attack those FRQs right away. And then the multiple choice, then you could really take your time and really go through those as it is. Here's the thing. Do your best. That's all we care about. Okay? Process, right? It's a process. We're progressing. And appreciate you being here. Y'all, we are going on an hour and I think it's been an hour and 10 minutes. Yeah, hour 12 minutes. Good podcast tonight. Have a great night. We'll see you and see y'all. Bye.